Welcome back to Electron Devices and Circuit lecture video series. In this video, we are going to discuss about JFET parameters. After watching this video, you will be able to understand the different parameters of JFET, that is DC drain resistance, AC drain resistance, transconductance, amplification factor, input resistance, and power dissipation. We will see this one by one. First thing you need to know about what is parameters. What is the importance of getting knowledge about the parameters of any device means when you consider a single device, for example, if you are taking JFET, so JFET is not only provided by a single manufacturer. N number of manufacturers are available in the market for providing JFET. So while selecting the JFET for our applications, and we have to classify the JFET, so there are some terms needed to differentiate the single device given by different manufacturers or by same manufacturers and different specification. So one such a term we call it as parameters. So parameters is nothing but the term used to define any device or classify any device for specific our applications. We call this as parameters. So like that, in this category, we are going to discuss 6 parameters with respect to JFET. The first one is DC drain resistance, represented by capital R ds. By Ohm's law, you know, drain resistance is nothing but V by I is the formula. So here this is the resistance on drain source terminal. So we are taking drain source voltage with respect to drain current. So this is the resistance. So how to find this drain source resistance means, so while getting the device from the shop, some specifications will be given by the manufacturer for that device. That means we can able to use this device up to this much maximum limit of drain source voltage. If we increase the voltage beyond that value, it will enter into breakdown region. So that voltage is the VDS voltage and ID is the maximum current. Maximum how much current the device can able to supply, that is ID. By substituting these things, you will get the value of RDS. Whether this drain source resistance is acceptable for you for connecting further devices in the network. If the resistance is not matching, we have to go for some other impedance matching devices. Based on the application we are choosing, we have to fix this resistance. So this is DC resistance, which is otherwise called static drain resistance. Next one, AC drain resistance or dynamic resistance. It is represented by small r suffix d. The main difference between the static and dynamic means, static means at any fixed time. At any time, the voltage is on unique value, current is one unique value. That is static. Whereas AC drain resistance, dynamic means we have to change a small fraction of change voltage to small fraction of current. That's why we are taking change in VDS to change in ID at a constant VGS. So normally when you are considering the JFET, only 3 terms you have to keep it in mind. One is VGS and another one is VDS, that is drain source voltage, and another one is ID drain current. These parameters is available on the output terminal and this is the parameter that is available on the input terminal. So if you are taking any 2 voltages or any 2 parameters, the other one has to be kept as constant by default. So likewise, AC drain resistance is change in drain is available on output terminals. So resistance, you know, voltage by current. So change in VDS divided by change in ID, and third term is kept as constant VGS. So the next one is transconductance. So transconductance, you have to split this term as trans plus conductance, transconductance. It is represented by GM. So as I already told you in the previous video, we have plotted 2 characteristics of JFET. One is drain characteristics and another one is transfer characteristics. In transfer characteristics, what I told you, we have to take one parameter on the input and one parameter on the output. That is the meaning for transfer or trans. Like that, here also you have to take one parameter on the input and one parameter on the output. That is the meaning for trans. Conductance. Conductance is the reciprocal of resistance, you know. So resistance R is equal to V by I, whereas conductance can be written as conductance is G, that is equivalent to reciprocal of resistance, that is nothing but I divided by V. So I is nothing but So as I told you, we have to take one parameter on input and one parameter on output out of two parameters available here. So normally the current is a JFET is a voltage controlled device. On the input side we are having only voltage. So you have to take the voltage on the input side, and on the output side you are having both voltage as well as current. But here we have to take only the required is only current. So I have to take current alone, that is ID. So I can write the formula as GM is equal to change in ID by change in VGS. What is the third term? That is VDS. So the third term is kept as constant. So this is the formula for transconductance. So maximum drain current you know, gate source voltage, maximum voltage you know. By substituting that, this value will be available for different values of VDS, because transconductance depends on VDS. So whatever the value of VDS, the transconductance may vary. So accordingly we have to select the required value for our application. And fourth one is amplification factor. Amplification factor means FET can also be used as an amplifier now. So how much will be the amplification rate of a FET? That can be identified by using this formula. So amplification factor represented by mu, and amplification in the sense you know FET is a voltage controlled device. So amplification in the sense both numerator and denominator you have to take same parameter. So out of the three parameters available in the FET, so see here out of three parameters available in this FET, so which is the common parameter, voltage or current? So only voltage is available on input as well as output time. So amplification is with respect to voltage only possible in case of FET, because FET is a voltage controlled device. So amplification general formula means output voltage divided by input voltage. Normally output by input. So here amplification is with respect to voltage. So we are taking output voltage divided by input voltage. So output voltage is drain source voltage. Input voltage is gate source voltage. Whereas third parameter ID is kept as constant. So this equation, this formula can also be represented as mu is equal to, since ID is kept constant, so multiply and divide by ID for this equation. So you'll get, additionally you can able to get one relation between these three terms. That means del VDS by ID into ID by del VGS. So this term is nothing but VDS. So VDS by ID, no, VDS by ID is nothing but RD. So VDS by ID substituting as RD, and ID by VGS. So ID by VGS is nothing but GM. So GM. So we can also say that amplification factor is nothing but it is the product of AC drain resistance and transconductance of a FET. The next one is input resistance. Input resistance, you know, this is input voltage by input current. Input voltage is gate source voltage. Input current is gate current. What is the current circulating between the gate and the source terminal? This IGSS is nothing but gate source saturation current. Right? So when you, by using this formula, you can find the input resistance. And power dissipation in FET. Power dissipation. When it is either using as a switch or as an amplifier, how much will be the maximum power that is dissipated in the FET? That can be identified by multiplying power. You know the formula, power P equal to V into I. So V is VDS into I for ID. So you'll get the maximum power that is dissipated in the output terminals can be calculated. What is the maximum VDS and what is the maximum ID? So multiply these two things based on the specification details. We came to know about the maximum power dissipation in the FET. Why we have to calculate these things means because if the power dissipation is getting on increasing unexpectedly, if the power dissipation increases the specified value, means overheating of FET, the JFET will be there, and there may be some problem to the fabrications methods, or the transistor may not work properly, or whatever the thing that may happen. So we need to be very careful. So while choosing the device for our applications. So with this we are coming to an end of a video of JFET. So JFET we have discussed about the introduction and different types of JFET, that is an N-channel and P-channel JFET. We discussed about the construction and operation of N-channel and P-channel JFET, comparison between JFET and BJT. And these are all the parameters. These parameters, any of the parameters may be asked in 2 marks. So the formula we are going to use in third unit also. So keep it in mind. So hope you understand the video. Keep watching the video for getting updates about the next topic. Thank you.